Hello students, in this video we will be seeing about previous year NEET question papers for the topic called electromagnetic waves. So we will try to solve the previous year NEET questions from this particular topic and we will try to discuss about the various problems which are asked in the last 10 or 15 years of NEET. So before going inside the problems, let us just have a statistical analysis about the previous year question papers. So if you see this particular topic called electromagnetic waves, we will be having three different subtopics. The first one is origin of electromagnetic waves, characteristics of electromagnetic waves, electromagnetic spectrum. So in these three topics, if you see, the majority of questions were coming from electromagnetic spectrum, around 40% of questions were coming from that, and around 37% of questions were coming from origin of electromagnetic waves, and 23% of questions were coming from characteristics of electromagnetic waves. So this was the scenario for the last 33 years. But if you just have a look at the last 8 years, the majority of questions were coming from these two topics, origin of electromagnetic waves, around 36% of questions were coming, and around 36% of questions were coming from characteristics of EM waves. So equally from these two topics questions were coming, and around 28% of questions were coming from electromagnetic spectrum. Okay, so if you just see, more or less all the three topics have been given prior importance and majority of questions were coming from all these three subtopics. So what we will try to do is, we will try to solve different problems from all these three subtopics, like previous year questions, like in which genre they have asked. So we will try to solve all these three subtopics, which will be helpful for you for your preparation for NEET. Okay, let us now move on with the first question. The magnetic field in a plane electromagnetic wave is given by By is equal to 2 into 10 power minus 7 sin pi into 10 cube x plus 3 pi into 10 power 11 t into t. Calculate the wavelength. Okay, so here they are given the equation as By is equal to 2 into 10 power minus 7 sin pi into 10 power 3 x plus 3 pi into 10 power 11 t into t. Okay, so this is the general equation of the magnetic field in a plane of electromagnetic wave. Like they have given an equation like this. First you write the general equation where B is equal to B naught sin k x plus omega t. Okay, so this is the general equation of magnetic field in a plane electromagnetic wave. So when you compare these two, you can easily get the k value. So k will be equal to pi into 10 power 3, because kx is here, pi into 10 power 3 x. Okay, so we know that k is equal to 2 pi by lambda. So they want us to find out the lambda. So you are just going to put here 2 pi by lambda is equal to pi into 10 power 3. So pi and pi will get cancelled, and you will be having the wavelength as lambda is equal to 2 into 10 power minus 3 meters. Okay, so the correct answer is option number C. So it's a very simple problem. Just you are making use of this equation of magnetic field and you are comparing both the things. Okay, the given equation with the general equation, and you are taking the k value. So k is 2 pi by lambda, and you are substituting it and you are finding out the wavelength. Okay, let us now move on with the next question. A parallel plate capacitor of capacitance 20 microfarad is being charged by a voltage source whose potential is changing at the rate of 3 volt per second. the conduction current through the connecting wires and the displacement current through the plates of the capacitor would be respectively 60 microampere, 0, 0, 0, 0, 60 microampere, 60 microampere, 60 mA. Okay, so here they want us to find out what is the current through the plates of the capacitor, and here what happens is the capacitance of the capacitor is given as C is equal to 20 microfarad. Okay, so this is 20 into 10 power minus 6 farad, and rate of charging of the capacitor is given by rate of charging is given by dV by dt. So which is equal to 3 volt per second. Okay, so here the displacement current ID is equal to C into dV by dt. Okay, so which is equal to 20 into 10 power minus 6 into 3. Okay, because C is 20 into 10 power minus 6 and dV by dt is 3. So if you solve this, you will be getting the displacement current as 60 microamperes. Okay, so here you can see what happens is, as the conduction current and displacement current will be equal, you will be getting IC is equal to 60 microamperes. Okay, since both are equal, you will be writing it as displacement current and the conduction current is equal, you will be writing it as 60 microamperes. Okay, so here the correct answer is option number D. Okay, so they have given it wrong as MA, it is microamperes. Okay, so the correct answer is option number D. So the conduction current and displacement current are both are equal and the value is 60 microamperes. Okay, let us now move on to the next question. An electromagnetic wave is propagating in a medium with a velocity Vi. The instantaneous oscillating electric field of this electromagnetic wave is along plus y axis. Then the direction of the oscillating magnetic field of the electromagnetic wave will be along. So here the direction of propagation of an electromagnetic wave is along E cross B. So wave velocity, that is E cross B, is along the x axis. Okay, so E cross B is along x axis. So electric field will be along y axis. Electric field will be along plus y axis. So this implies, according to the vector product rule, B will be along the z axis. Okay, so B will be along the z axis. So the correct answer is plus z direction. Okay, so option number B. So it's just a direction of propagation of an electromagnetic wave along the E cross B. So here they have given you the wave velocity Vi is that is E cross B is along the x axis. So wave velocity is along the x axis and the electric field is along the y axis. So according to the vector product rule, the magnetic field B will be along the z axis. So the correct answer is option number B. Okay, let us now move on to the next question. In an electromagnetic wave in free space, the root mean square value of the electric field is ERMS equal to 6 volt per meter. The peak value of the magnetic field is, okay. So here ERMS is given by E naught by root 2, okay. But we know that E naught is equal to C into B naught, and you are going to substitute this value of E naught over here. So you will be getting E RMS is equal to C B naught by root 2, but they want us to find out the peak value of the magnetic field. So you know the value of ERMS, they have given it as 6 volt per meter, okay. So and you know the C value, it is speed of the light 3 into 10 power 8. So B naught will be root 2 E RMS divided by C. So which is equal to B naught is equal to root 2 into 6 divided by 3 into 10 power 8. So if you solve, you will be getting the value of B naught as 2.83 into 10 power minus 8 Tesla. Okay. So this is the peak value of the magnetic field, 2.83 into 10 power minus 8 Tesla. So the correct answer is option number B. Okay. Let us now move on to the next question. A 100 ohm resistance and a capacitor of 100 ohm reactance are connected in series across a 220 volt source. When the capacitor is 50% charged, the peak value of the displacement current is. Okay. So here they are giving you the RC circuit, series circuit. So for an RC series circuit, you will be having Z is equal to root of R square plus XC square. So which is equal to root of 100 square plus 100 square, because they are giving you the resistance value as 100 and 100 ohms and 100 ohms of reactance. So both are 100. So you will be getting it as 100 square plus 100 square. So which is equivalent to 100 root 2 ohms. Okay. So you have got the impedance value Z. Now the peak value of displacement current is given by I naught is equal to V naught by 2. Okay. So this is the peak value of the displacement current, V naught by Z, sorry, V naught by Z. So V naught is again equivalent to VRMS root 2, VRMS root 2, because VRMS is V naught by root 2. So you are getting it as VRMS into root 2 divided by Z. Okay. So here you have got the Z value as 100 root 2 and your VRMS is 220. They have given you the voltage as 220. So 220 root 2 divided by 100 into root 2. So if you solve this, you will be getting the current value as 2.2 amperes. So the correct answer is 2.2 amperes. The correct answer is option number B. Okay. So first we are finding out the impedance value, and then you are finding out the displacement current, peak value of displacement current by substituting the V naught and Z values. So V naught is found by using the VRMS value, and which they have given in the question as 220. Okay. So if you substitute that, you will be getting the peak value of the displacement current. Okay. Let us now move on to the next question. The electric field associated with an electromagnetic wave in vacuum is given by E is equal to I 40 cos k z minus 6 into 10 power 8 t, where E, Z and T are in volt per meter and seconds. Okay. So E is in volt per meter, Z is in meter, and time period is in seconds respectively. the value of wave vector k is, okay. So first you write down the electric field equation. E is equal to I 40 cos k z minus 6 into 10 power 8 t. So now you are going to consider the standard cosine form of equation of electric field. Okay, so the standard cosine form of equation of electric field is given by E is equal to E naught cos k x minus omega t. Okay, so now if you compare these two, you will be getting the omega value as omega equal to 6 into 10 power 8. Okay, so it is 6 into 10 power 8 radians per second. Now the wave vector k is given by the formula omega by c. Okay, so k is equal to omega is 6 into 10 power 8 divided by 3 into 10 power 8. So this if you solve, you will be getting it as 2 meter inverse. So the value of k will be equal to 2 meter inverse. Okay, so the correct answer is option number A. So first thing is you are writing out the equation which they have given, and you are considering the standard cosine form of equations of electric field, which is E equal to E naught cos kx minus omega t. When you compare this, you will be getting the value of omega, which is 6 into 10 power 8. So from that you can easily find out the wave vector k is equal to omega by c, and you are substituting and finding out the value as 2 meter inverse. Okay. So let us now move on to the next question. The ratio of amplitude of magnetic field to an amplitude of electric field of an electromagnetic wave propagating in vacuum is equal to. So it is equivalent to the speed of light in vacuum, the reciprocal of speed of light in vacuum, the ratio of magnetic permeability to the electric susceptibility of vacuum, and unity. Okay, so here in order to solve it, first we need to understand the concept of magnetic field and electric field and all its related informations. So we need to have a study about the relationship between electric field and magnetic field. Okay, so we know that a magnetic field is a vector quantity which describes the magnetic influence or an electric charge of another moving charge. So a charge that is a magnetic field that is perpendicular to its own velocity and magnetic field. Okay, so here we know that electric and magnetic fields both are interrelated to each other and both are components of the electromagnetic waves. So we know that C is equal to E naught by B naught. Okay, and whereas here they have asked you the ratio of amplitude of magnetic field to the amplitude of electric field. So this is magnetic field and this is electric field. So we need to take the ratio of these two. So it will be B naught by E naught is equal to 1 by C. Okay. So what happens is the ratio of the amplitude of magnetic field to the amplitude of the electric field for an electromagnetic wave in vacuum is equal to the reciprocal of speed of light in vacuum. Okay. So it is reciprocal to the speed of light in vacuum. So the correct answer is option number B. It is the reciprocal of speed of light in vacuum. Okay. So just making use of this equation, E naught by B naught equal to C. But in this question they have asked you the ratio of magnetic field to the amplitude of electric field. So just inverting it, we will be getting it as 1 by C. So the correct answer is option number B. Okay, let us now move on with the next question. The electric and magnetic field associated with an electromagnetic wave propagating along the z-axis can be represented by. So here electric and magnetic fields associated with an electromagnetic wave are always perpendicular to each other. So also the velocity of the electromagnetic wave is given by, the velocity is given by c is equal to E cross B. So as c is along z axis, E and B are along plus x and plus y axis respectively. Okay. So if you see here, so the correct answer is option number A. Okay, why we are choosing option number A is here the C is along the Z axis. So E and B will be along the X axis. So E will be along I and B will be along Y axis, that is J axis respectively. So E will be equal to E naught I, so which is in the X axis, and B will be along the Y axis, so which is equivalent to B naught J. So if you just compare this, you can see the answer is option number A, where E is equal to E naught I and B is equal to B naught J. Okay, let us now move on to the next question. The electric field of an electromagnetic wave in free space is given by E is equal to 10 cos 10 power 7 t plus kxj volt per meter, where t and x are in seconds and meters respectively. It can be inferred that the wavelength lambda is 188.4 meter, the wavelength number k is 0.33 radians per meter, the wave amplitude is 10 volt per meter, the wave is propagating along positive x direction. Which of the following pairs of statement is correct? So they want us to find out which statement is correct. So first you write down the equation. E is equal to 10 cos 10 power 7 t plus kx j. Okay, you are going to compare this with the electric equation, general equation. E is equal to E naught cos omega t plus kx. Okay, so you will be getting the omega value as 10 power 7 radians per second, and E naught will be 10 volt per meter. So since E naught is 10 volt per meter, statement 3 is correct. So here the statement is the wave amplitude is 10 volt per meter. So statement 3 is correct, and you know that the wave vector k will be omega by c, so which is equal to 2 pi n by c or 2 pi by lambda. So lambda will be 2 pi c by omega. Okay, so if you substitute that, you will be getting 2 pi into 3 into 10 power 8 by 10 power 7. So if you solve this, you will be getting it as 188.4. So the wavelength lambda is 188.4 meters. So option number 1 is also correct. Okay, so 3 and 1 is correct. Now if you see wave vector k is equal to omega by c, so which is equal to 10 power 7 by 3 into 10 power 8. Okay, so if you solve this, you will be getting it as 0.003 radians per meter. But here the wave number they have given it as 0.33, but it is 0.033 radians per meter. So option number 2 is wrong. So if you see, option number 1 and option number 3 is correct. So the correct answer will be option number D, since option number 3 and option number 1 are correct statements. Okay, so it is just a simple logic problem where you are writing the equation which they have given, and you are trying to compare that with the cosine form of the equation of electric field. Okay, so standard cosine form of equation of electric field, E is equal to E naught cos omega t plus kx. You are just trying to compare with that, and you are trying to get the value of omega and value of k from that, and you are trying to substitute and find out what is the wavelength, what is the wave number, and what is the wave amplitude. Okay, let us now move on to the next question. Light with an average flux of 20 watt per centimeter square falls on a non-reflecting surface at normal incidence having surface area 20 centimeter square. The energy received by the surface during the time span of 1 minute is. Okay, so here they want us to find out the energy received by the surface during the time span of 1 minute. So here they are giving you options like 12 into 10 power 3, 24 into 10 power 3, 48 into 10 power 3 and 10 into 10 power 3. Okay. So the intensity of incident light is given by I is equal to E by 80. Okay. So this is intensity of the light, I is equal to E by 80. So here they are giving you the intensity as 20, which is equal to E by surface area is 20 again into the time is 60 seconds. Okay, because they have told it is 1 minute, so we are converting into seconds, it will be 60 seconds. So if you solve this, you will be getting it as 20 into 60. So this will be 24 into 10 power 3 joule. So the energy received by the surface during the time span of 1 minute is 24 into 10 power 3 joules. So the correct answer is option number B. Okay. So it's a very simple problem, just you are making use of the formula of the intensity, and they are giving you the intensity value as 20 and they are giving you the value of the area and the time. So you are just going to substitute and find out what is the energy received by the surface. Okay. So let us now move on to the next question. Out of the following options, which one can be used to produce a propagating electromagnetic wave? A chargeless particle, an accelerating charge, a charge moving at a constant velocity, a stationary charge. So generally what happens is electromagnetic waves are produced by accelerated charge particles. Okay. So due to the acceleration of the charge particles, the electromagnetic waves are being produced. So the correct answer is option number B, an accelerating charge. Okay, it's a direct question. You can just simply choose the answer as accelerating charge. Okay, let us now move on to the next question. A radiation of energy E falls normally on a perfectly reflecting surface. The momentum transferred to the surface is C is equal to velocity of light. Okay. So we all know that energy of radiation is given by E equal to hc by lambda, and momentum of incident radiation is given by, it's P is equal to h by lambda, which is equal to E by C. Okay. So momentum of reflected radiation PR is equal to, this is incident radiation Pi, and PR is equal to minus of Pa. So it will be equal to minus E by C. So the total momentum transferred will be given by P will be equal to Pi minus PR. So it is E by C plus E by C, so which will be equal to 2E by C. So the correct answer is option number B. Okay. So you are just making use of the energy of the radiation formula E equal to hc by lambda, and the moment of incident radiation you are calculating Pi is equal to h by lambda, which is equal to E by C. Okay. You are just substituting from this. So from this you can take h by lambda as E by C. That's what you are substituting it here, and the momentum of the reflecting surface will be in the opposite direction. So it will be PR equal to minus of Pi. So it is minus E by C, and the total momentum transferred is given by Pi minus Pr. That is the difference of the incident momentum and the reflected momentum. So you will be getting it as Pi minus Pr, and when you add that, you will be getting it as 2E by C. Okay. So the correct answer is option number B. Okay, let us now move on to the next question. Light with an energy flux of 25 into 10 power 4 watt per meter square falls on a perfectly reflecting surface at normal incidence. If the surface area is 15 centimeter square, the average force exerted on the surface is. So here, since wave is totally reflected, momentum delivered to the surface is 2U by C. So you will be having the average force is equal to 2U by C by T. Okay, so momentum delivered to the surface is 2U by C. So average force will be 2U by C by T. For unit time, what happens is F average will be 2 into S A by C. So where S is the energy flux. So here they are giving you the energy flux as 25 10 power 4 into the area is 15 centimeter square. So 15 into 10 power minus 4. We are converting it into meters. So 15 into 10 power minus 4 divided by 3 into 10 power 8. So the average force will be 250 into 10 power minus 8, or F average is equal to 2.5 to 10 power minus 6 Newton. Okay. So the correct answer is option number B, 2.5 to 10 power minus 6 Newton. So this is the average force exerted on the surface. Okay. Let us now move on to the next question. Which of the following statements is false for the properties of the electromagnetic waves? Like they have given us 4 options. The first one is both electric and magnetic field vectors are attain the maxima and minima at the same place and same time. So if you see, what happens is the electric field and magnetic field varies continuously with time, and they will be always having a maxima and minima at the same place and at the same time. Okay. So this is a true statement. So this cannot be a false one. Next, the energy in electromagnetic waves delivered equally between electric and magnetic vectors. So again, if you see here, the energy in the electromagnetic wave is divided equally. So both the electric and magnetic field have the same energy. So this is also a correct statement, it cannot be a false one. And if you see the third one, both electric and magnetic field vectors are parallel to each other and perpendicular to the direction of propagation wave. Okay. So here what happens is it's not parallel. Both electric and magnetic field are perpendicular to each other and perpendicular to the direction of propagation. Okay. So this one is a false statement, and these waves do not require any medium for propagation. Yes, of course, they don't require any material medium for propagation. They can also propagate in vacuum as well. Okay, so they can also propagate in vacuum. So this is a correct statement. They don't require any material medium for propagation. So the only false statement here is option number C, where they are given both electric and magnetic field vectors are parallel. But we know that both electric and magnetic vectors are perpendicular to each other. So the correct answer is option number C, which is a false statement. Okay. Let us now move on to the next question. The electric and magnetic field of an electromagnetic wave are, again they have given you some options here, in opposite phase and perpendicular to each other, in opposite phase and parallel to each other, in phase and perpendicular to each other, in phase and parallel to each other. Okay. So we know that the electromagnetic wave travels like this. Okay, so here you will be having the y component z and x. So we know that this will be the electric field and you will be having the magnetic field in this direction. Okay, so this is the electric field and this one is the magnetic field. Okay, so you can draw like this for differentiating it. Okay, so you can see that they both are in phase, but they are perpendicular to each other. Okay, they are perpendicular to each other. So the correct answer is option number C. So both electric and magnetic fields are in phase, but they are perpendicular to each other. So the correct answer is option number C. The next question is the ratio of contributions made by the electric and magnetic field components to the intensity of electromagnetic wave is. So here they want us to find out what is the ratio of the electric field and the magnetic field components to the intensity of the electromagnetic wave. So generally the intensity of the electromagnetic wave is given by I is equal to UAVC, where UAV is the average energy of a wave. So average energy of a wave means we have two components. One is average energy in terms of electric field and another one is average energy in terms of magnetic field. So the average energy in terms of electric field is given by UAV in terms of electric field is given by half epsilon naught E naught square, and similarly in terms of magnetic field UAV is given by half B naught square by mu naught. Okay, so we know that C is equal to E naught by B naught and C is equal to 1 by root of mu naught epsilon naught. Okay, so we are going to just substitute the values over here. So this value is over here and here you will be getting it as UAV electric field, that is in terms of electric field is equal to half epsilon naught B naught square C square, because E naught is B naught into C, so you are substituting it here, and again for C you are going to substitute, which is equal to half epsilon naught B naught square into 1 by mu naught into epsilon naught. So this epsilon naught and epsilon naught will get cancel each other and you will be getting it as B naught square by 2 mu naught. So you can see that the average energy in terms of electric field is equal to the average energy in terms of the magnetic field. Okay, because both are having the same value. So when you go with the ratio will be 1:1. So the correct answer is option number A. Okay, it's a very simple problem where first you are trying to find out the intensity of the electromagnetic wave, which is equal to UAV into C, and UAV is the average energy of a wave, and we have the average energy in terms of electric field and the magnetic field respectively. So you are just substituting the values of C, which is equal to E naught by B naught, and from that you are taking E naught, and C is equal to 1 by mu naught epsilon naught. You are just substituting and you are finding out both the average energy in terms of electric field and magnetic field are equal. So their ratio will be 1:1. Okay. Let us now move on to the next question. The electromagnetic wave with the shortest wavelength among the following is microwaves, ultraviolet rays, X-rays and gamma rays. So we all know that the electromagnetic spectrum comprises of starts from gamma rays and it ends at radio waves, and we know that the energy, as we progress from gamma rays to radio waves, the wavelength will increase and the energy will decrease. Okay, because we know that E equal to hc by lambda, and E is inversely proportional to the wavelength. So, as the wavelength is increasing, the energy will decrease, and we all know that the gamma rays will be having a highest energy and it will be also having the shortest wavelength. So, the correct answer is option number D. Okay, it is a direct question, just you are going to make use of the electromagnetic spectrum and find out which is the shortest wavelength, and the longest wavelength will be radio waves in the electromagnetic spectrum. Okay, let us now move on to the next question. Which color of the light has the longest wavelength? Okay, so which color of the light has the longest wavelength? And here they are given you green, violet, red and blue. So, if you see the colors, all these colors are a part of the visible spectrum in the electromagnetic wave spectrum. Okay. So, we know that you will be having like this gamma rays, then comes the X-rays, then comes the UV, then comes the visible. So, in this visible, this will be the final one, radio waves. Again we have IR and microwave. Okay. So, in this visible spectrum, we will be having the 7 colors. So, which is Vibgyor. Okay. So, the 7 colors is Vibgyor, and generally violet starts from 4000 angstroms and red ends around 7000 angstroms. So, in this if you see, the highest longest wavelength will be the red color will be having the longest wavelength, which is around 7000 angstrom. Beyond red color you will be getting the IR spectrum in the electromagnetic spectrum. Okay. So, due to this longest wavelength only, red colors is being used in signals also for giving an alarm at a larger distance, and in most of the cases like in building tops and all, they will be using this red color light to give a intimation for the flights also that some kind of an obstacle is present. Okay, because of its longest wavelength, it can be easily visible at a larger distance. So, the correct answer is red, option number C, which is having the longest wavelength. So, if you just remember this particular electromagnetic spectrum, you can easily solve all these questions, which are very simple concepts. Okay, generally the electromagnetic spectrum starts with gamma rays, X-rays, UV, visible, IR, microwave and radio waves. So, as you go through from gamma to radio waves, what will happen is the energy will decrease and the wavelength will increase. So, with this concept you can easily solve all the questions making use of this particular logic. Okay. Let us now move on to the next question. The energy of electromagnetic waves is of order of 15 kilo electron volt. Okay. And to which part of the spectrum does it belongs to? Okay. So, as I was saying you will be having E is equal to hc by lambda. Okay. So, here the h value is 6.6 into 10 power minus 34, we all know that, and C is 3 into 10 power 8. So, here what they have given you the E value as 15 kilo electron volt. So, it is 15 into 10 power 3, you are converting the electron volt in joules. So, you will be getting it as 1.6 into 10 power minus 19. Okay. So, you are just going to find out what is the wavelength. Lambda is equal to hc by E. So, it is equal to 6.6 into 10 power minus 34 into 3 into 10 power 8 divided by 15 into 10 power 3 into 1.6 into 10 power minus 19. Okay. So, if you solve this, you will be getting it as around 0.825 Armstrong. So, which is lambda is approximately equal to 1 Armstrong. So, it is approximately equal to 1 Armstrong means it belongs to the X-ray region of the spectrum. So, the correct answer is option number B. Okay. So, generally the wavelength of X-rays will be around to 1 Armstrong. So, you are getting it around 0.825 means it is nearer to 1 Armstrong. So, this energy is corresponding to the X-ray, like in the electromagnetic spectrum it is corresponding to the X-ray region. Okay. Let us now move on to the next question. The condition under which a microwave oven heats up a food item containing water molecule most efficiently is. So, microwaves are heat waves, so always producing heat. Infrared waves produce heating in a microwave oven. The frequency of the microwaves must match the resonant frequency of the water molecules. The frequency of the microwave has no relation with natural frequency of water molecules. Okay. So, here if you see, to transfer the energy of the microwaves efficiently to the kinetic energy of the water molecule in the food items, generally the frequency must match for both the things. Okay. So, the condition here is under which the microwave heats up the food is when the frequency of the microwave matches with the resonant frequency of the water molecules. So, the correct answer is option number C. Okay. So, when the frequency of the microwave matches with the resonant frequency of the water molecules, automatically the food gets heated up. Okay. Heated up efficiently. Okay. Let us now move on to the next question. The decreasing order of wavelength of infrared, microwave, ultraviolet and gamma rays is. So, here they are giving you options like microwave, infrared, ultraviolet, gamma rays, ultraviolet, infrared, microwaves, microwave, gamma rays, infrared, ultraviolet, infrared, microwave, ultraviolet, gamma rays. So, if you remember, I was saying you about the electromagnetic spectrum, which I have drawn and shown in the previous questions. So, if you just remember this, you can easily solve this question. It starts with gamma and it ends in radio waves. In between, you will be having X-rays, you will be having UV, you will be having visible, you will be having IR, you will be having microwaves. Okay. So, if you see the question, what they are asking is the decreasing order of wavelength. So, here what happens, the wavelength increases, and if you want to see the decreasing order, you have to go in the reverse way. So, first comes microwave and then comes IR and then comes ultraviolet and then comes gamma. Okay. So, it is microwave, IR and then UV and then gamma. So, if you see in this option, option A is the answer. Okay. It is a very simple question. Just if you remember this, you can easily solve all these kinds of questions. So, electromagnetic spectrum starts with gamma and it ends at radio waves, and as you go from gamma to radio waves, the wavelength of the electromagnetic spectrum increases. Okay. So, let us now move on to the next question. If lambda V, lambda x and lambda m represents the wavelengths of visible light, X-rays and microwaves respectively. Okay. So, lambda V is visible light, lambda x is X-rays and lambda m is wavelength of the microwaves. So, same concept, you can just draw the electromagnetic spectrum, gamma rays, X-rays, UV, visible, IR, microwave and radio waves. So, here if you see, the microwaves will be having a larger wavelength. So, lambda m will be greater than, next comes the visible, will be having a larger wavelength, lambda visible and then the X-rays, lambda x. So, the correct answer is lambda m greater than lambda v greater than lambda x. So, the correct answer is option number C. Okay. So, lambda m, the wavelength of microwaves will be greater than the wavelength of visible light and will be greater than the X-rays. Okay. Let us now move on to the next question. Which of the following rays are not in electromagnetic waves? X-rays, gamma rays, beta rays and heat rays. So, here if you see, we know that X-ray is a part of an electromagnetic spectrum. Heat rays means microwave rays. Okay. So, MW, microwave rays is also a part of the electromagnetic spectrum, and gamma rays is also a part of the electromagnetic spectrum. So, the only ray which is not a part of the electromagnetic spectrum is beta rays. So, the correct answer is option number C. Okay. So, beta rays is the only one which is not part of the electromagnetic spectrum. So option number C is the correct answer. Okay, let us now move on to the next question. The frequency order of gamma rays, X rays and UV rays is, so again the same way. Okay, you will be having gamma, X rays, UV, visible, IR, microwave and radio waves. So you know that E equal to h mu. So the energy will increase and also the frequency also increase when you move in this direction, towards this direction. Okay, so here the frequency will be very high for which one you will be having gamma rays, X rays and UV. Okay, so they are given the frequency for gamma ray as B and for X ray as A and UV as C. So as we know, the frequency will be, the high energy is for gamma rays, and since frequency is directly proportional to mu, you will be having gamma rays as the highest frequency. Okay, so B is greater than A is greater than C, because X rays will be having a larger frequency order in comparison with UV, because the energy of X rays is also larger than the UV. So the correct answer is option number A. B is greater than A is greater than C. So the frequency order of gamma rays is greater than the frequency order of X rays, and it is also greater than the frequency order of the UV rays. Okay. So if you just remember this particular electromagnetic spectrum order, you can solve all the problems so easily, and you should also remember the energy equation E equal to hc by lambda, and you should understand the concept that as you increase from gamma rays to radio waves, the wavelength will increase but the energy will decrease, and similarly the frequency also will decrease. When you are coming in the reverse way, the wavelength will decrease and the energy and frequency will be increasing. Okay. Let us now move on to the next question, which is also a similar kind of a question. Which of the following electromagnetic radiations have the smaller wavelength? So same way, you are having the gamma rays, X rays, UV, visible, IR, microwave and radio waves. Okay. So if you see, the smaller wavelength will be, here they are giving X rays, gamma rays, UV and microwaves. Okay. So the smaller wavelength will be ultimately for gamma rays. It is a repeated question. You can see this was asked in 1994. A similar kind of question was also asked in 2000s. So a kind of similar questions only, it was repeatedly asked, and which is directly you are going to say the answer from the question. From just seeing the electromagnetic spectrum itself, you can easily find out that the shortest wavelength will be for gamma rays. They will be having a lesser wavelength, but the energy will be higher for them. Okay. Let us now move on to the next question. The structure of solids is investigated by using cosmic rays, X rays, gamma rays and infrared radiations. Okay. So here again we know that the X rays will be having a wavelength of in the range of 1 Armstrong. Okay. So this wavelength is suitable for diffraction to occur. So we know that Bragg's law, n lambda equal to 2d sin theta. So when Bragg's condition is satisfied, the X rays will diffract on a crystal structure. Okay. So you will be having a crystal structure like this. Okay. With different planes, you will be having it like this. So what happens is, the X rays will be having a wavelength which will match with the interplanar spacing. It will match with the interplanar spacing. So the diffraction occurs when X rays falls on a material or a crystal. The diffraction occurs because the condition of diffraction is satisfied, where the X-ray wavelength is matching with the interplanar spacing. So ultimately the diffraction occurs when it is being incident on a material. So you can easily analyze the structure of solids with the help of X-rays because of the wavelength of the X-ray matching with the interplanar spacing. Okay. So due to this, people use this X-ray diffraction as a tool to analyze the structure of the material. Okay. So I think this video would have been useful for you to understand the previous year question papers related to the topic called electromagnetic waves. And as I was saying you, only 3 topics is there in this particular unit. The first one is the origin of electromagnetic waves, the characteristics of electromagnetic waves, and the last one is electromagnetics. So try to give importance to all these 3 subtopics, and especially if you see the electromagnetic spectrum, just remember the electromagnetic spectrum which I have shown you, like it starts from gamma and X, UV, visible, IR, microwave and radio. So if you understand that particular electromagnetic spectrum, you can easily sort out or easily solve so many problems related. Okay, so you know, as we increase from gamma to radio waves, the wavelength of the material increases, and similarly energy and frequency decreases. Okay. So I wish you all good luck for your exams. Prepare well, and thank you for